We've got new people in class today as well. Hi, Ann, what's up? How are you?
I am fine.
All right. Been a very long time, Ayan. Where were you? Hmm?
Uh,
Hmm. The only issue was that Nofal was taking classes with me. That is why I was surprised that you weren't here. He was very regular, but it's all right. Okay, let's continue. Apologies to Zoya and Kushi and I think Saad and the rest because these were guys were early. And Honey is joining again for some reason. All right, guys. Where were we the last time? We were going to do differentiation. All right, so let's begin with that today. In our last class, we saw that, linear equations and quadratic equations, how are they different from each other? What just happened? All right. So we saw that, um, how quadratic and linear equations are different from each other and what sort of significance does the quadratic equation hold. All right, that's really important too. And we saw how that it's going to have, what sort of effects do the constants have, what is C and stuff of that sort. If you're asked to find the x-intercepts, that means that they're asking for solutions to the equations or real roots to the equation. And then simply we said that the gradient is non-uniform for curves. And there are two ways of finding out the gradient. The first one that we did was by finding out the gradient of the tangent and by finding out what you may call mm, um, by finding out the gradient of the tangent because the gradient of the tangent and the gradient of that point on the curve are going to be the same. And then yesterday we more or less did this question where I told you guys to draw a gradient and stuff. Today let's go by differentiation. All right. This is one topic that I really enjoy because right now it's all going to be, all rainbows and candies in IGCSE. But this exact same topic, um, okay, first of all, who among all of you who is considering taking A level maths? Raise your hands. Who is considering taking maths as an A level subject? Oh my God, there's a bunch of people. Who's left? Who's not taking A level math? I think every one of you are taking A level math. Is further maths easy, sir? Yes, Basit, very easy. It's probably even easier than IGCSE math. Obviously not, Basit. Further is difficult. It's detailed in math. All right, only Hayan is the one that's not going to be taking math, and the rest are taking math. That's good. That's a good thing. That is good because you guys should take math. It's a good subject. It opens up your options. Your career options are open. But now comes the bad news because right now I'm going to tell you about differentiation. And it's going to be so easy for you guys because you're going to be like, oh, I just have to do this, and everything will be so easy, and all rainbows and glitter and stuff. This same topic is going to make sure that it's let's just say that it's not going to be as easy as it is right now in A levels. Let's just say that. I don't want you guys to be extremely scared. It's not going to be very difficult, but this is probably one topic that is going to continue further the most. Like your entire A level paper is probably like a lot of it is going to be based on your knowledge of this differentiation. All right, so let's begin with it. Let's see what we can do. Differentiation, if I tell you guys what it is simply the relationship, or you're trying to see, if I put it in much simpler words, differentiation is when you're trying to see what is the effect that one quantity has when you change another quantity. So you're trying to see change in one quantity with respect to another quantity. For example, it's kind of like proportions, you can say, but not entirely. All right. In theory, it's kind of like proportions. Like you're trying to see what sort of change one quantity is going to bring in the other quantity. Clear? All right. It is going to be determined by what you may call differentiation is going to be determined by. Wait, let me do it separately. So if we're trying to, why is it not working? Wait, guys, just give me a moment. Pencil is glitching for some reason. All right. So differentiation is very simply um, the change that we experience in one value with respect to another. It is denoted by D, or some people even call it a curly for some reason. I don't know why, but I've always called it a D. All right. And okay, now I'm not going to go into detail because it's irrelevant at your level. Differentiation at your level is just there to find the gradient. How? If you differentiate a quadratic equation, it is suppose, or any equation for that matter, what you're going to do is that you're trying to see a any equation for that matter is an equation in y written in terms of x. So if you're differentiating that equation, technically what you're trying to see is what sort of change in y is going to arise due to change in x. So at your level, it's going to be dy upon dx. Change in y, which is equal to change in y over change in x. You're trying to denote that. And change in y and over change in x is actually equal to what, guys? It is equal to your gradient. So your differentiation actually helps you to find the gradient. That's what it does. All right. Is this clear? Is there anyone who has any questions regarding this? Now, how do you differentiate? Let's move on with that. Hmm, who to ask? Hayan, you're new here. Yes, Hayan. Tell us what do you give me an example of a quadratic, any equation. Okay, make it quadratic. Give me an example of a quadratic equation. Hayan, can you hear me?
Yes, I can hear you.
Then can you give me an example too?
Um, ax square plus bx plus c is equal to 0.
Okay, that is perfectly all right. But I want an example where you not in A, B, and C terms. I want an actual example. Like give me an example as y is equal to something something. All right. You've told me the general term. Yes. Tell me this, Hayan.
Uh, 6x square minus
Right.
16x plus 12 is equal to 0.
Okay, I'll keep it equal to y. Okay. So it's 6x squared minus 16x or 60.
16.
1 6 plus 12.
Yes.
All right, there's this equation, and they tell you to find the derivative. Take, calculating the, deriving something or doing differentiation on an equation is kind of like calculating the derivative of that equation. So if the question says find dy upon dx. Now, we obviously know that finding the derivative is going to lead me to the gradient, but the gradient of a quadratic equation is not constant. So, whenever you're going to use differentiation to calculate the gradient of a quadratic equation, it is going to give you some sort of function. It is going to give you some sort of function, or it is going to give you some sort of smaller equation. And through that equation, you can find the gradient at multiple points on the curve. And we'll see that. All right, let's see. So you've got y is equal to 6. Wait, let me write it down with a bit of gaps. 6x squared. Okay, too much gap. Minus 16x plus 12. Okay. Now, guys, I'm going to find the derivative. So it's going to be dy, which is change in y according to change in x. What you're supposed to do? Let's see. Rewrite the entire thing down. All right. The power on top of the variable, whichever variable it is, usually it's going to be x. The power on top of the variable is taken to the front and multiplied. So if the power is 2, you multiply with the power. And one other thing that you do is alongside this, first you take the power to the front to multiply. Secondly, you subtract 1 from the power. The second thing that you have to do is that you have to subtract 1 from the power. So two things have to happen. The original power, which is 2, was taken to the front to multiply. I subtracted 1 from the power as well. All right. Do not think that after subtraction I have to take it. No, the original power has to be multiplied at the front. Okay. Over here, the power of x is not visible, so it's common sense that it's equal to 1. Right? 1. You take it to the front to multiply. So multiplying with 1. And you subtract 1 from the power. Clear? Okay. Who can tell me what is the power of x over here? Yes. Yes, sir.
It's 0.
All right, sir. But there is no x, so what should I do? Hmm?
You don't write 12.
You don't write what?
You don't write 12.
Okay. All right. Yes, Basit, you're raising your hand.
Nothing.
All right. No worries, Basit. Zoya is absolutely right. If there is no x over here, that means x is raised equal to 0. Why? Because we already know if x raised to the power 0 is equal to 1. All right. We already know this. This is information known to us. So if x is raised to the power 0, because there is no x over here, so technically there should be 1 over here. You take 0 to the front. Because it's a power, right? The rules remain rules. You take 0 to the front, you multiply by it, and you subtract 0 and 1 from 0. Now, let's try to write down what has just happened. So your new expression for dy upon dx is going to be equal to what? 2 times x, which is 12. X raised to the power 2 minus 1. 2 minus 1 is 1. So x raised to the power 1, which I can simply write down as x. Don't really care if it's 1 or not. Okay, what has happened over here? Minus 1 times 16 is 16. X raised to the power 1 minus 1. 1 minus 1 makes the power of x is equal to 0. We already know that x raised to the power 0 is equal to 1. So completely x is gone. So I'll just write 16 plus 0 multiplied by 12 multiplied by x. When 0 multiplies with anything, regardless of what is happening, the answer is 0. So instead of writing that, there is. And you get this. Now, what is this? This is known as your gradient function. Why is it known as your gradient function? Because technically your derivative should be equal to your gradient. But this is a quadratic equation. So because it is a quadratic equation, your gradient isn't going to be what you may call constant or uniform for the curve. So that is why when you take out derivative of a quadratic equation, it gives you a formula to find the gradient, or it gives you a gradient function. And in that function, you can put in values of x to find the gradient. So how will I do that? The second part of this question usually states that find the gradient at x is equal to 1. Oh, x is equal to 1. Because it's a curve, right? You cannot find the gradient of the entire curve because it's changing. You need to find the gradient of one point on the curve. So if I've chosen 1, as in, like x is equal to 1, what you're simply going to do is put x is equal to 1 in dy upon dx, because that is equal to your gradient. So it is going to be dy upon dx is equal to 12 times 1 minus 16, which is equal to 4 minus, by the way. And that is your gradient. M at x is equal to 1. Yes. Is there anyone who does not get this? Yes. Is there anyone who does not understand what has just happened? Yes, guys. All right. Hayan, is this clear?
Yes.
What about you, Basit?
Clear.
All right, Basit. And Honey, what about you? Hopefully, it's clear for Honey too. Honey, just so you know that we can't hear you.
Yes.
All right, Honey, now we can. Okay, let's try to. I'm going to cheat a little. Oh, this is a question from the previous paper that I gave you guys. What you're simply going to do in this question is part one of this question states find the expression for dy upon dx. All right. First, everyone do part one, then we'll do part two. And whoever is done first, raise your hand, please. Let me crop it. Whoever is done first, kindly raise your hand when you're done. All right, so that we can discuss. Whoever gets this question right, I'll probably give them like a bonus mark in the quiz. And I just remembered that I have to check those two. Yes, I will. Fahad is already done. Wow. Yes, Fahad. Fahad,
Yes, sir.
you're done.
Yes, sir.
That's unfair, Fahad. I was thinking of resting. All right, Fahad is already done. Fahad gets the bonus mark. No, it depends. Was the bonus mark on doing it quickly, or was the bonus mark on getting it correct, Fahad?
Sir, I think it was on getting it correct and quickly.
Hmm. For your honesty, Fahad, I will give you a bonus mark. All right, Fahad. gets the bonus mark. All right, Fahad, let's just wait for the other ones to do it too. That was really quick, Fahad. Are you sure you've done it correctly?
I think.
Hmm. Zoya and Saad. Saad did it and then Zoya did it. All right, guys. Let us wait for the other ones too. Ranim has done it as well. Well done, Ranim. All right. Basit has done it. Nice profile picture, Basit. Is it new? I think.
Yes, sir.
Yeah, I think I've seen it today. Is it an anime character or what is it?
Sir, I just found it on Google account.
Okay, all right. No worries. Basit, you were randomly scrolling Google to get profile pictures for your Gmail account.
Yeah.
Well done, Basit. Utilizing time. That's good. All right. Don't worry, Basit. I did the same too. Hmm. I'm thinking of changing it too. My mine is like a fat panda and it's pink, which is fun too. All right, Hayan's done. Who's left? Ishal is left and only Ishal and Hani are left. Let's see who's the last one. It's a race. It's so much fun. Hani's done it. I think Hani's just raised her hand. Hmm. Yep, told you. All right. Ishal, are you there? Assalamu alaikum. Ishal is here. I don't know why I cannot hear Ishal. All right, Ishal. Hopefully you've done it as well. All of these guys are done. Okay. Fahad will guide us through this. Yes, Fahad. Guys, put your hands down.
Sir, do I just tell the answer?
Okay, tell us the answer.
Sir, 3x squared plus 4x minus 4.
Right, wait. 3x squared plus 4x squared or something
No, sir, it's only 4x.
minus 4.
Yes, sir.
Whosoever agrees with Fahad, raise your hand. Is there anyone who disagrees with Fahad apart from Ishal? Because we've seemed to lost all contact with Ishal. All right, everyone supporting Fahad. What can I say? Fahad's got friends. Can we solve it? Let's check. Let's try to burst Fahad's bubble. All right, guys. You guys were really quick to get this. This is actually really good. So it's going to be y is equal to x cubed plus 2x squared minus 4x. And if I calculate the derivative, it's supposed to be you take power to the front, so it's 3x and you minus 1 from the power. So it's going to be 3 minus 1, which is equal to 2. Plus, you take power to the front again, so 2 times 2 is 4x and you subtract 1 from the power, which is 2 minus 1, which is equal to 1. You shouldn't write it. And over here, x has the power of 1. You take it to the front. 1 times 4 is 4. And one thing that I think I misplaced telling you, I did not change the sign, guys. If you guys notice that the signs carry forward with me. But okay, let's do this in another example. I'll explain this too. And minus 4, because x, if you subtract 1 from the already given power of 1, it's going to be 0. So it's going to be 4. Yes, unfortunately, Father is wrong because he said like 6x or something. He said that. So apologies. Every one of you is wrong. I win. No bonus mark for anyone. All right. So now what's going to happen is that, okay, let's see if you guys can earn the bonus mark now. Well done on this. Hmm. Find the gradient at x is equal to 3. Whoever does it first gets the bonus mark. Does it first and does it correctly, like Fahad said. Ooh. I think Zoya did it first. Right? Zoya raised the hand first. Because it shows to me that it's the raising of the hand as first to last. Hmm. Zoya wins it this time. Fahad, you were so close. Zoya, tell us the answer. What is Zoya's answer? Let's see. Here's Zoya.
I got 35.
Whoever agrees with Zoya, raise your hand. All right. Almost all of you agree with Zoya apart from Basit. Basit, why don't you agree? No, Basit does agree. Raneem doesn't agree. No. Raneem, you don't agree with Zoya? What's wrong? Hello, Raneem.
No, sir, I got the same answer.
All right, Raneem. Thank you. All right, let's see. What's the answer? The bonus mark depends on it. So I'm just going to put x is equal to 3 over here. So it's going to be 3 times 3 squared plus 4 times 3 minus 4, which is going to be equal to 3 times 9 plus 12, I think, minus 4. 3 nines are what? 27 plus 12 minus 4. It should be equal to what? It should be equal to 35, I guess. And apologies, Zoya. You got it wrong. I got it right. So no bonus mark again for you guys. Why are you getting it so wrong all the time? All right, well done. You guys have caught on very quickly. I was not expecting you guys to catch on this quickly. Okay, wait, let's do a question. Any reason why you guys are raising your hands still? Any question? Anyone has? Basit, you have a question? No. All right, wait, let me move forward. Let me take out a question, guys. Wait. Hmm. Okay. This question, let's see if you guys can do this. Okay, whoever does this question too, they're also eligible for the bonus mark in the quiz. Okay, let me wait. First. This is too easy, but I am giving it to you. It's a good thing that you guys are, you've caught on very quickly to this. Usually it's a difficult topic for students. That means you're not as dumb as I think you guys are. It's a good thing too. Okay, do these 2 questions. I've posted down 2 questions. Let me know when you're done. And whoever does it first is obviously eligible for some bonus mark. Also, you guys have to raise your hand when you're done, otherwise I won't know. Bingo. Hello, Fahad. Yes.
Sir, I'm done.
How so far? This is wrong. Where did the other guys go? How do I exit you from the full screen? Oh,
Sir, you unpin me.
when did I pin you? Oh, that's not working. Oh, okay. Now it didn't. Fahad, who are you taking help from?
Sir, no one.
Are you sure?
Yes.
This is suspicious on another level. Is Yumna sitting with a calculator beside you?
So this does not require a calculator.
Yeah, that is true. What about like Google something, Lens or something? You guys are much more
So
smarter than.
I think that would take more time than just solving it.
Hmm. And Basit is done. Wow. Well done, Basit.
Sir, if you don't mind, can you like move this thingy so I can see the second question?
Ooh, Zoya is fighting so hard to try to get the bonus mark. Wow, you guys beat Zoya. She's been on fire recently. Hmm. And Hani's done too. Oh, by the way, Basit and Hani, do you have a question or are you guys done?
Done, sir.
You're
I'm
done?
done, sir.
Well done, then. Well done, very well done. Wait, give me a moment. Yes, everyone's done. Okay, who did it first? Yes, we were talking to Fahad and his mysterious ways of getting work done quicker than all of you. Yes, Fahad, can you tell us what answer did you get for the first part?
So 3x squared plus 7x minus 2
Wait, that was too quick. Uh, you got 3x squared.
plus 7x minus 2.
Whosoever agrees with Fahad, raise your hand. I only heard like, oh no, a lot of people agree with Fahad. Everyone agrees with Fahad. All right, well done, Fahad. And the second question, who was the second one that did it? Basit did it, I think. Yes, Basit. Can you tell us?
-3 answer, sir.
-3 is the answer. Who agrees with Basit? Raise your hand. Oh, the hand raises have gone down. Saad does not agree with Basit. Whoever does not agree with Basit, just shout out your answer to me. Is there anyone who does not agree with Basit? All right, I think all of you have made your point clear. You guys agree with us. Well done. This was like surprisingly very well done, actually. I am impressed. I was not hoping you guys to understand differentiation on the first go. All right, I was underestimating the students in my class. That is something. All right, let's continue. So, um, you use differentiation to calculate the gradient at any given point. Let me draw a curve. Let me draw a curve. At this point, guys, can someone tell me, first of all, what is this point? Fahad and Saad, you've got your hands up. What's up? Oh, you were asking about the answer. You're telling the answer or something? Okay. Yes, Basit. What is this point?
Minimum point.
Minimum point? Okay, yes. Basit is right. This right here, this guy right here, is known as the minimum point, or it can be even be the maximum point. Like, for example, if I flip this, now it's a maximum point. Flip it again, it's a minimum point. So it depends on the graph what point is this. This is known as the minimum or the maximum point. This is known as what you may call the minimum point or the maximum point. It is also known as your turning point. Why is it known as your turning point? Because after this, the graph actually takes a turn. It is also known as your stationary point. Why is it known as your stationary point? I still don't have any idea too, but you can call it. I think it's because of the fact that it's not going anywhere. It's rested at the top, stationary. All right. This is your minimum, maximum point, your turning point, and your stationary point. What do you think is the gradient at this point? Raise your hand. Yes, Zoya.
It's 0.
Why, Zoya?
Because there's no change in y. So yeah, that equals to 0.
All right. Perfectly all right, Zoya. So, guys, what Zoya is saying is that if there is no change in y, and why is there no change in y? Well, that is because of the fact that if I were to draw a tangent at this point, it would be perfectly horizontal. Obviously, not like this, but it would kind of be just like this. It would only touch that point. Let's just zoom in and see that this is very accurately drawn. That the tangent is touching this point, and we already know that a perfectly horizontal line, we saw this a few classes ago, has the gradient equal to 0. So the minimum or the maximum point or the turning point or the stationary point, at this particular point, your gradient is equal to 0. Is this clear, guys? At this particular point, your gradient is equal to 0. Oh, this is dotted. And now what's going to happen? Because your gradient is equal to 0, your gradient, isn't it equal to your derivative? So therefore, full circle moment, your derivative is also going to be equal to 0. So if I want to find the turning point of my graph, like this point or this point, whichever point it is, minimum or maximum, I am going to calculate the gradient, which is this, and I'm going to put it equal to 0. Why? Because when I put it equal to 0, at that point in time, we're actually trying to calculate the gradient of the turning point. So if I put the gradient equal to 0, that is going to lead me to the x coordinate of the turning point. And further, it's going to lead me to the y coordinate of the turning point as well. But I'm going to leave you guys in suspense till tomorrow for this. But we're going to do this in detail tomorrow. All right. Any questions so far regarding this? Is there anyone who still doesn't get this?
No, sir. Okay.
All right. Guys, just give me a moment. Let me just take your attendance. Please just give me like a second. Otherwise, I'll forget. Today is Tuesday, right? Yeah. So, Basit is here. Ishal is here. Fahad's here. Asim isn't here. I don't think so. Raneem is here. Hayan has made a comeback after all this time. Saad's here. Hamdan's absent. Hani's kinda absent, but she's here. Zoya's here. Khushi is here. And Hafiz absent. Clear? All right, guys. Thank you for your time. Looking forward to seeing you tomorrow. I know the feeling is not mutual for you, but keep smiling. With you guys tomorrow. Allah Hafiz. Bye bye.
Allah Hafiz, sir.
Bye, sir.
Bye. Allah Hafiz.